Hello everybody, my name is Walter, and this is episode 81 of my Redstone Commands Series. Today I would like to show you how you can use Minecraft commands to dynamically assemble a written book whose content you only know at the point of generation and not beforehand, so you can't statically predefine the content yourself. For this example, I'm going to have a look at one of my databases I released a while ago, centered around this armor stand, which counts the blocks, entities, and items inside of this area here, and gives for one a chat report, which I covered in the previous episode, but also a full and a minimized book report. So let's have a quick look at those two. So the full report just lists all of the blocks, entities, and items that could be counted, and where we have actually a count, we have a number, and everything else is left blank basically. We also have some jump marks at the top we can use to get to the start of each chapter, but all of this here is completely static. The dynamic book report, on the other hand, looks a bit different. Here we only have the entries that actually have something to tell us, where we actually have a number. And we also have our jump marks, and all of this here is dynamically generated, which you can see if I were to go over here. Now I've changed a setting in the background, and if I now generate the minimized book report anew, I now only have 3 entries per page, and you can see the page numbers have been correspondingly adjusted, and all of those jump marks still work. And I can also reset this again by setting some MBT data in the armor stand under controls and entries per book page, and down value is 12, and I have set it intermittently for 3. So anyway, let's also quickly have a look at the MBT data of the armor stand itself. So you can see, if we look in there, the armor stand has under data for one controls, which I covered partially in the previous episode. For us today is only interesting the entries per book page, which is set to 12 at the moment. And then we have counts, where all of the values that the counting has given us are stored, plus some additional values that are generated during the book generation. And yeah, how all of this here works together to generate a proper dynamically assembled book report we'll cover in the following. So first things first, let's start with the basic idea of how all of this here works. For that we need 3 layers. At the bottom we have our JSON text snippets. Each, in my example, is a single line, but you can also just have them be part of a continuous text. They may or may not be conditional, so they may be part of the dynamically assembled book, or they may not be part, depending on whether the conditions are fulfilled or not. Or they may be also somewhat static and always be in the book. Then we have the page we're currently assembling. This is basically an array of JSON text snippets. And then we have the finished book pages, which is an array of those finished pages. So an array of those JSON snippets. Additionally, we have for the current page a counter, which we are using to determine when we need to flip to the next page. And this can be a line counter in my example, or it can also be a character counter. So depending on which you use, you increment by 1 for each snippet you add, or by the length of the snippet in characters basically. And yeah, now let's just go through an example. So we have our, in this case, 10 snippets we want to assemble into a book, depending on whether they pass or fail the conditions, obviously. And we just start with the first snippet and check, okay, that has to be in the book. We put it in the current page, increment the counter, and then we do the same for the second part. This apparently needs to be also part of the book, so we also add it to the current page. The check for the third fails, so we simply ignore it and skip to the fourth, which now becomes part of the book again. Now let's say we have a line limit of 3, so we have reached our threshold. And now we move the complete content of the current page into the end of the finished book pages, clear the current page, and reset the counter. And then we continue in this case with the snippet number 5. And we do this over and over until all of our snippets that have passed the test are in the finished book pages. And at that point, the last step left is just copying this into a written book we, for example, freshly summoned. And with that covered, it's now time for the actual implementation. Here, for comparison's sake, let's start with the full book report, which is static. So it only contains a single give command for the nearest player who gets a written book with a predefined written book content. And the only, in a sense, dynamic part here is whether the MBT data exists or not in the MBT data of the armor stand. If it doesn't exist, then the entry line doesn't have a number at the end. If it exists, then that number is simply copied in. But aside of that, the entire book is fully predefined. There are no surprises there, basically. The dynamic book report, on the other hand, is a bit more complex and starts at initialization. So this function here is called during loading or reloading of the game. And of interest for us is just the last line here, which sets the entries per book page to 12 if it doesn't already exist. So this is the default value. On a side note, at self, so the executor of all of those functions here is the armor stand that contains all of the counts and values as MBT data. Next up, we have the function that is called when we trigger the book generation in the chat menu, and that is this dynamic book report function. In here, we do some initial calculations, so we determine the targets for our jump marks essentially, and then trigger the actual book assembly. But let's go through this. So first, since we need to do math, we prepare a scoreboard objective here called the sector2 counter. Then we extract the entries per book page from the MBT data of the armor stand and store it as a score for our maths later on. Make sure this value is between 3 and 13 inclusive, since we don't want the pages to be too long or too short. And then we calculate how many pages we need for each chapter. For that, we initialize the score with value 0. And then we go through the various blocks, entities, and items we count. And only if we have found that block, this MBT data here exists, and only if it exists, then we increment the counter by 1. So we are counting how many entries we actually need in our final book, which we do for all of the blocks first until we are done. And at that point, we decrement by 1, divide by entries per page, and add 1 to that result. Now, to understand this, you have to know that the division for the scoreboard command always rounds down. But to get the number of pages I need to round up. So I'm subtracting 1, dividing with round down, and adding 1. This is effectively something like a round up and gives me how many pages I actually need for all of those entries to fit in. And if that number is greater than 0, then I add under counts a value for block or blocks total, which is just the number of pages the blocks chapter will have. Only if this here exists. This is important because if this doesn't exist, then I later on don't add a normal page, just a dummy page. But we'll come to that in a bit. And the same repeats itself for entities and items. The math involved is exactly the same. The values are just called slightly different, so entities total and items total. But the idea is the same. Then we calculate the actual page numbers for our jump marks. So this is just, okay, we have an initial front page. So the starting value for blocks chapter, so blocks start, is set to page 2. Then we calculate the same for the entities chapter and finally the items chapter. So just basically offset by the start of the previous chapter plus the length of the previous chapter, and then we have basically the actual start of the current chapter. Yeah, and then in case we found nothing, so no blocks, no entities, no items, then we also give a final short chat message to the player. Okay, there was nothing found. We will still generate a book, but it's basically empty. Then we trigger the actual book assembly. And then finally, once we're done with that, we clean up the storage and the sector counter again. Now, once we're done with the pre-calculations, we call this assemble book function here, which itself starts with a function call for the front page function, which, as a first step, modifies the storage for the book pages to an empty array. So we start with a blank book, essentially. And then it adds the first page, so the front page, as a whole to those book pages. So this is completely static, so we can do it as a predefined book page. And it also prepares the current page with an initial value of being an array with just an empty string as the first entry. You can see something similar, by the way, over here. And the reason is JSON text is kind of stupid in the current Minecraft. If you add something like making the first entry in an array bold or maybe give it a color or whatever, this is set as the default for the entire array. So if you don't want to have to say for every following part, I don't want this in bold, I don't want this in a specific color, I don't want this to be underscored or whatever, just add an empty string in the beginning and you don't have to worry about that part. That is the reason why I initialize this with an empty string. So once we have the front page in place, it's time for the first chapter. And here the first step is setting the page line to entries per page. This will, the moment I try to add an entry, automatically force a page break, which is not entirely necessary for the first step here, but for the following chapters, it might be necessary. So I also have it in there to follow the same pattern. Then I set the chapter page to 0. This is a counter that basically is used for the header later on. So we know, okay, we are on page 2 of 7 of the logs chapter, for example. This would be chapter page 2 then. And yeah, following that, we start to go through all of our entry lines. And as with the pre-calculations, we check if the corresponding count actually exists. So we have found that block. And if that is the case, then we call the function addEntry with lots and lots of additional information. We'll have a look at what happens in there in a bit. But this pattern just repeats for all the blocks we're counting. So you can see this is quite a bit. Until we hit the last block we're counting here. And then we have one additional check, and that checks if a certain entity there doesn't exist. And we're checking for blocks total. And if you remember back to the previous function, this only doesn't exist if we haven't found any blocks we're looking for. And in that case, I'm adding a dummy page for my blocks chapter, again with some additional information. So that function I can already show you since it's pretty straightforward. So this is the dummy page blocks function. So we force a page break. So this is again for the blocks chapter not necessary, but for the later chapters it is more or less necessary. And then we add the full dummy page as is to the book pages area. Then we continue with the second chapter for entities. And this follows exactly the same pattern, just for various entities. And then we have the items. And then, once we're done with the last chapter, we have a final page break in case it's necessary. And then all that's left is summoning in an item. In this case, well, a book, a written book with some additional information in there, specifically also a tag, so I can target this specific book later on. And then I copy the content over with a function call or within a function that is called, and this is the assemble book final function. We will have a look at this a bit later as well. But before that, let's look at the addEntry function. Now the first thing we do is incrementing the page line counter by 1, since we have 1 entry per line. Then we check if we're still on the same page. If that is the case, then we call return, which means all of the later commands in this function here will not be executed. And then run a function called addEntryLine with some additional information. And this line contains just a page break, then the name of the block entity or item we're counting, and then finally the number of that count. So pretty straightforward. If this here failed, so we need to make a page break, the first thing we do is call a function new page. And this function first copies the current page onto the end of the book pages if it's longer than 1 entry. So remember, it's preset with an array only containing a single entry, an empty string, which would have the index 0. And the moment I add something to that, I have at least something with an index 1 in there. So if it makes sense, then we copy it onto the book pages so we don't have empty pages in there later on. Then we're resetting the current page again, and also the page line back to 0. And that's already the new page function. Once we have the new page, we increment the chapter page counter by 1, since we now are on the next page. And now I'm using a little trick to store the current chapter page, which will be part of the headers later on, under a unique name in the NBT data of the armor stand. For that, I'm assembling the name of that NBT data as page underscore and then the name of the count I'm counting. So this is unique, and I can make use of that for my page counter, basically, to store this permanently. The reason here is all of this NBT data is only taken from the entity the moment the player opens the book. Not the moment it's generated or given to the player. It's the moment the player actually opens the book. So I have to more or less permanently store that information. That is why I need a unique name, which I'm constructing here. This is later on also referred here as current page in the function header underscore and then blocks entities or items, which we can also have a quick look at right here. So again, I'm just adding parts of the header as text to the current page. And over here, I am referencing the current page. And that is how I can have in my headers then, okay, you're on page 2 of 7 or whatever. Yeah, that is how that part works. So we have the new page, we have a header, and then we just add the missing new entry line. I have a corresponding function if you have comments. So there is no count, but there is some text we want to have in the book additionally. It works exactly the same as the add entry function. The only difference is that we don't call an add entry line function, but just directly add the new text. So line break and then the comment to our current page. That is the only difference here. And yeah, with that, we're basically done. And the last function to look at is the assemble book final function, which first copies the book pages into the book. On a side note, this function here is executed by the written book, which is currently lying on the ground as an item. This is the only function here that is not executed by the armor stand. So, but as I was saying, it copies from the storage the book pages into the written book content of the written book. Then it removes the specific tag I gave it to be able to address it earlier. And then it copies or it teleports the book to the nearest player. And that's already how the book gets assembled and then given to the nearest player. And with that, we've reached the end of this episode about dynamic book generation. I hope you enjoyed this episode. I wish you a nice day and well, see ya.